Hi, welcome. Today's lesson is on significant figures, doing addition, subtraction, multiplication, and division. And I'm Miss Backus, and
I'm Mrs. Cooper. When we're performing operations with significant figures, there's a very general rule, which is when we're combining these measurements that have different degrees of accuracy and precision. If you don't remember these terms, they are in the graduated cylinder video. You can always go back to it. The accuracy of the final answer cannot be greater than the least accurate measurement.
that means like if I have a piece of bad data and a piece of good data, I still can only get bad results, right?
Exactly, yes. You will use the one that has the worst accuracy.
Right,
That's the one you will be using.
Okay, for addition and subtraction, we're going to look at the decimal places. Remember, our answer cannot be more accurate than our individual data. Let's take a look at this example. I have a number of 12.6 centimeters, and that has three significant figures and one decimal place. So 3 sig figs, and it goes to the tenth of a place. If I add that to another number, 1.21 centimeters, which also has three significant figures, but this time it has two decimal places. It goes all the way to the hundredths place, right, Mrs. Cooper?
Yeah, so it's different. We see that the first one has just one decimal place. We're talking about the tenths, and this one has two decimal places.
So when I add this in math class, I would get 13.81. And I suggest to add this just like in math class first, but then we're going to not stop there. We're going to do a little bit more, and we're going to round the answer. So I have an answer of 13.81 centimeters. That's the math answer.
Yes, it is. And we see that we have two decimal places in our answer and four significant figures.
I can only be as good as my worst one. So now I have to go back and see which one is worse. So I have something that only goes to the tenths place and something that goes to the hundredths place. And I'm going to kind of forget about how many significant figures for this and just look at the place. So I have one to the tenths place, one to the hundredths place. Well, the tenths is not as good as going to the hundredths place.
Exactly.
So my answer can only go to the tenths place, right?
Yes. We cannot use two decimal places in this case because that would not be correct with our least accurate measurement.
Right, and it makes sense too. If I'm not sure about this 6, right, that's my uncertain place. If I'm not sure about this 6, when I add them together, means I'm not sure about this 8. So if I'm not sure about this 8, there's no way I'm sure about the 1, right?
No.
So that doesn't count. So it's 13.8 is the correct answer.
Now, I see, Ms. Backus, that you did some rounding there in that last problem.
Yes, I did, and we didn't talk about that.
Yeah, so let's see what that is. When an answer has more significant figures or decimal places than the ones you need, you must round it off. So these are the rules that we're going to follow. If the last digit is smaller than 5, so we're going to drop it and leave the remaining numbers unchanged. Here we have an example. We have, this is our last digit, and we want to round to the hundredths place. So we check here the 4 is smaller than 5, and we drop this number, and the 3 remains unchanged.
If I am rounding to the hundredths place, I look at the thousandths place and see if that number is bigger or smaller than 5, right?
Exactly. Yes.
Okay.
So always one place to the right than the one you're rounding to. In this case, it was the hundredths. We look at the thousandths. And if it's greater or equal to 5, then we drop the number and add 1 to the preceding digit. For example, here we have, we want to round it to the hundredths place. So we look at the thousandths and we see it's an 8. This is greater than 5. So we're going to drop this number, and don't forget, we have to add 1 to the preceding digit to the hundredths place. So our answer is 2.35.
Students may have heard this before as rounding up or rounding down. So we are going to be rounding up if it's greater than or equal to 5. Instead of 2.348, it rounds up to 2.35.
Exactly.
Okay.
Yes.
That seems to make sense. What about rounding from the last example? We rounded, but we didn't talk about it, so let's go back and look at it. I said 13.81 became 13.8. How did I do that? I look at this, and I have 13.81, and so I need to decide, do I get rid of this 1 or do I round up? Well, 1 is less than 5, so I can just get rid of it, and I don't have to change this 8 at all. If I'm going to round this to the 10th place, I'm kind of thinking in my head, is this closer to 13.8? 13.9. Well, it's closer to 13.8 than 13.9, so I can just get rid of that 1, right?
Exactly. We just drop it, and our final answer, we see that it has just 1 decimal place, just like our least accurate measurement.
That's good.
So here we have more examples on addition and subtraction. Let's take a look at the first one. We have this number, and remember, with addition and subtraction, we're not going to look at the significant figures, but at the decimal places.
The decimal place.
Those are the ones that are interesting here. We have 2 decimal places. We see that it goes all the way to the hundredth place. This number here, 372.1, has just 1 decimal place, so it's the 10th. And when we do this operation, we subtract, as we do in math, in a regular math class, we have 63.88. Now, here this answer has 2 decimal places, and I only need 1 because my least accurate measurement has only 1 decimal place. So I will look at the 10th place, which is the one I'm interested in, and I will check the number to the right, and I see that this number is greater than 5. So I will drop the number, but before doing that, remember, you have to add 1 to the preceding number. So we get 63.9 meters.
All right, well, that makes sense. 63.88 is closer to 63.9 than it is to 63.8.
It is, and that's why we can't round it down to 63.8 because we're actually closer to the 0.9.
All right, that makes sense. What about the next example?
So here we have another example, and this time we have more decimal places.
Wow, that's a lot.
Yeah, so the first one has 5 decimal places, and the second number, this is an addition, has 3 decimal places. Ms. Backus, do you remember the rule, which number of decimal places we're going to use for our answer?
I do. I have to use the worst one. So 5 is really good. 3 is not so good. So I can only have 3 in my answers.
And we're going to use 3. So when we do this operation, we add, and when we do this in our calculator, you can do it by hand, it's pretty easy. We get 5 decimal places. Now we only need 3, so we have to check our third decimal place will be the 6th, and we check the number on the right. It's a 3. That means that it's smaller than 5. We're gonna drop it.
So I can just get rid of it, right?
Yes, we just get rid of it. There's no need to add 1 to the 6th to our thousandth place, and along with the 3, we drop the 4.
We drop everything after that, right?
Exactly, everything else.
We drop everything else. All right, I think I'm getting the hang of this. We're still working on addition and subtraction, but what if I don't have any decimal places? What am I going to do then?
Oh, well, that's a very good question.
Yeah.
Because we've been working with the decimal places. What happens if we don't have any?
Then I am going to have to look at the place of uncertainty. I'm going to have to remember the rules that I learned in the significant figures video.
Okay.
Here I have a number, 1300, has no decimal places. The decimal places are easy because it tells me right away where the plus or minus is. This doesn't have any decimal places, so I have to remember from the video, this could have been plus or minus something in the ones place, plus or minus something in the tens place, or plus or minus something in the hundreds place. Because this person doesn't give me any more information, I don't know which one it is.
Yeah.
So if I don't know that, Mrs. Cooper, what do I have to assume then if I don't know if it's the ones, the tens, or the hundreds place?
Well, here, what we can do is we can look at this digit. This is the last one that we might guess that was certain. So the 3 here with our hundredths place.
Right, because I use the same kind of rule. Well, I'm going to take the worst case scenario, right? Yes. So I have to assume that this is something plus or minus in the hundredths place. This really went to the hundredths place, not the decimal place, but the hundredths place. This one, once again, I don't know if it's ones or tens, so I have to take the worst case, which is the tens place. What happens when I add them together? Well, I get 1320 like I do in math. But we're not in math class,
Oh,
no.
no, this is chemistry.
This is chemistry. So I can't leave it as 1320. I was uncertain in the hundredths place and uncertain in the tenths place, so I have to take the worst of those. Well, the worst of those is the hundredths place. So now I have to round it to the hundredths place. So I look at the number after the hundredths place, and it's a 2. Well, that tells me it's a number less than 5. I can just drop oh no, I can't just drop it. If I just drop these numbers, I would round this to from 1320 or 1320 down to 13.
Oh no, that's not the same number.
No, so I can't just drop them when they're not decimals. I've got to put zeros in their place. So instead of dropping these like you can when there's a decimal point, I can't drop these. I have to keep a 0 in its place. So here is my final answer, and that's kind of funny. We have 1300 plus 20 still gives me 1300 because this 20 wasn't significant at all. There we have it.
Very good. I didn't know that. That's something that I should remember.
So what about multiplication and division?
Multiplication and division it's pretty much the same rule. However, in this case, we're counting significant figures. So we're going to stop looking at the decimal places and we're going to start counting significant figures. Remember, our answer cannot contain more significant figures than our least accurate measurement.
This again goes with that rule. I can't have bad data and good data and end up with good results.
No, you will end up with bad results.
I'm going to end up with bad results. So I can't get better than my worst case, right?
Exactly, yes. Our first number has 3 significant figures, and here you see that we still wrote the number of decimal places that we have. We're not going to look at the decimal places. We're just going to look at the significant figures.
Just the significant figures this time.
Here, 1.349 grams has 4 significant figures, so our worst measurement will be this one with 3 significant figures. We do the operation, and we end up with 5 significant figures, so it's way better.
Yeah, that would be like dancing in the street data or results. We can't get that when we don't have that in our data.
Exactly. This is not possible. Again, our answer has to have 3 significant figures. And what we do here is we look for 3 significant figures and we have to see if we have to round it up or down. We check here the 8 is greater than 5, so that means that we have to drop this and add 1 to our hundredths place. So we would get 9.04.
All right, well that makes sense. Now we're looking at significant figures and not decimal places. But the process is still very similar.
Yes.
Here are a couple more examples of that. Now, notice we're not even going to write the decimal places because we don't need that.
No, that's just for addition and subtraction.
Here I have 2 significant figures, so hopefully you remember that I won't count these. 1, 2 significant figures. This one is great. 1, 2, 3, 4, 5 significant figures. You should be dancing if you have this. When I put this in my calculator, I get something ridiculous that says like you have 10 significant figures.
Wow.
Wow.
Can we use that one?
No, we cannot use that. Don't put this number down, all right? I can only use the worst of these. I have 2, which is so-so data, compared to dance in the street data. Well, my results can only be so-so also. So, well, that's a lot of so's in that sentence. I'm going to have to round this to 2 significant figures. So I look at my 2 significant figures, that's 5 and 9, and then I go to the next one to the right, and that is less than 5, so I can just drop it, and I can just drop all of these. So I'm getting rid of everything, and it rounds to 5.9 grams.
Ms. Backus, I have a question.
Good.
What would happen if instead of dropping them, I wrote zeros?
Oh, that would be wrong. Also, that's a very good question. If you wrote zeros here, all right, like you might want to do when you're rounding a number that is bigger than 1, if I wrote zeros in a decimal, that says those are significant also. So I would still end up with 10 significant figures if I change all of these to zeros. So that still would be wrong. That would say I had this really fabulous result.
Okay,
and I
so
didn't.
I can't do that, right? So I have to stick to my worst number of significant figures.
Right.
So only 2 in this case.
Only 2. So let's take one more example here. I have 4 significant figures. 1.001 is 4. Here I have 3 significant figures, 7.34. I put in my calculator and I get something like this, which is 6 significant figures. Wow. So don't get calculator crazy. This is wrong. I have to go back down to, so Miss Cooper, do I go back down to 3 or 4?
Well, we have to do 3 because that's the data that has the least number of significant figures.
All right, so I have to look at the number to the right of my 3. So 7.34 gives me 3, and then I have to decide what I'm going to do with this end. Do I get rid of it? Do I add 1 to here? Well, this number 7 is greater than 5, right?
Yes.
So I'm going to drop it still, but that's not all. I better add 1 to this. Instead of 7.34, I'm going to be 7.35.
Well, that was easy.
Hey, are we done then?
Yes, we're done.
Well, don't forget to write down all of these rules, and remember, addition and subtraction, you look at the place, the decimal place, or the ones or the tens or the hundreds place.
Yeah.
But what do I look at when I multiply and divide?
That would be the number of significant figures.
And in both cases, I have to take the worst of my data.
All the time.
All the time. So addition and subtraction, you look at the place. Multiplication and division, you look at
significant figures.
There you have it. Thanks for listening.
See you in class.
See you in class.